Hey everyone, Forrest here with Fofo Astro, and today I want to take a look at a little custom project that I just finished, and I really wanted to share it with you guys because I think it's something super doable that if you are a handy person really at all, it's something you could totally handle. So one of the big concerns with a remote observatory, like I've talked about in other videos, is remote power control. And I've talked a little bit about this in my prior videos, but building your own remote relay controller is actually super easy. I was really intimidated by it to start off with just because it sounded like I got to learn coding, I got to learn how to work with an Arduino, I got to continue my knowledge on electronics. It sounded overwhelming, but it's actually a really simple system. So I want to show you guys that today and just give you a little bit of a breakdown and tell you that if you have an observatory that's, a few hundred feet away and you want to be able to power cycle those items without having to walk out there, in my case you're miles away, it's a pretty easy process to do. So the first thing that you've got to do is you've got to wire a Arduino relay controller into your system. And I'm bringing one up on the screen right now, but basically you get these on Amazon. They're around about 10 or 15 bucks, and you get one that has enough relays in it for the devices that you want to power on and off. And this looks like a mess of cables, but it's actually really simple. I have a positive power line coming in here, and I have a negative power line coming in here. And if I take this fuse box controller off, fuse box cover, which is really easy, basically this main positive power line comes in here and supplies positive voltage, positive 12 volts to all of my different devices. So if you are running off of 110 power and all your devices are 12 volt, you might get a converter that converts the 110 to 12, and you too can have a little fuse box. And it's nice to fuse everything because then if one thing has problems, it doesn't fry your whole system. So let's take this for example. Positive voltage comes in here. This little wire right here, this 4 amp fuse, is for my main network switch. It's something that sometimes I need to be able to power remotely. I need to be able to turn it on and off. Let me zoom in there. So we've got the positive voltage coming in. We can see this plus wire. And then if I trace it, you can see it's connected to this other wire that goes into my mysterious black box. And then the other end of that wire goes out and goes down through here and over to my network switch. And then the negative side of that network cable winds all the way back through the whole observatory and comes in right there. And then that is connected to the negative side of the battery. So real simple. Basically, we're supplying positive and negative voltage, or positive voltage and ground, however you want to talk about it. But in the middle of the positive voltage side, we are putting it through a relay box, which again, I put those links down in the description so you guys can see. So very simple, and you can feed as many of your circuits through that relay as you want to. Each circuit needs its own relay, and a relay is just a way to power something on and off electronically. Now, you'll notice there's a wire coming out of my black box, and that wire feeds all the way down here, up here, there it is, into this little blue box, which is my Arduino. So there's a little Arduino in there. Now Arduinos cost like 20 bucks, and this is just your standard Cat5 Ethernet cable, so nothing fancy here. Well, basically this wire has signal wires inside of it. There's 4 twisted pairs inside of an Ethernet cable. They come into the Arduino, and the Arduino is able to send voltages through those wires to tell the relays what to do. Now, this sounded super confusing, and I was like, well, this is clearly above my pay grade. Just Google a web Arduino relay controller, and you'll find people who've actually put their code there in order to do it. Now, you'll notice, very simple, my Arduino is connected directly to the relay controller, or the relay box. It's also connected via USB to the NUC. Now that is purely a power connection. All the NUC's doing is giving the Arduino power. I also have it so the Arduino can get updates from the NUC. If I need to change the code, I can push an update through there. But if I had a 12 volt power cable for the Arduino, which I could do, this USB cable is not necessary. So don't think that the NUC is doing anything. The NUC is just there right now to power the Arduino with this cable. The Arduino is plugged with network cable into my main network switch, which we've talked about before. It's right down yonder, right there. That's the main network switch. And the reason that we do that is because that way, if this Arduino makes a little web server, like I'll show you guys in a minute, I can log on to that web server remotely and control what the Arduino does through this networking cable. So all you need is Arduino, some signal wires, a relay controller on Amazon or a relay box on Amazon. You can get the Arduino on Amazon as well. And then it's hooked up to your main network controller, and most of your stuff is probably networked anyway. If you have a remote desktop computer or something like that, it's going to work. So let's go ahead and look at the software side of things, and I can show you guys how simple that is. All right, so here we are on the observatory NUC, which is part of the observatory network, obviously. And I can access this whether I'm here or whether I'm VPN'd into the network out here, however I want to do it. But the cool thing is if I'm part of the observatory's network via plugged in or wireless or whatever it is, I can go on any browser, and I can do this on my phone, I can do this from anywhere, and I just have to go to 192.168.1.199. Actually, sorry, that's the wrong IP. 192.168.1.200, which is what I actually set my Arduino to be for its IP address. And you set that when you code the Arduino. Again, do a little Googling and you'll find that. Now, what my Arduino does is a couple things. For one, it measures the voltage of the battery. I use that for some other things that are the topic of a later video, which is a safe, unsafe controller. It also gives me the history of voltages that the Arduino has experienced. It also tells me whether it's safe or scorched earth, as I call it, which is really low voltage, but that's not the topic of this video. Topic of this video are these buttons right here. So here's the thing. This was super simple code. In fact, we're talking like a couple hundred lines of code, which may sound super overwhelming, but when you get into it, a lot of it is copy and pasted and repurposed from other people. And what this allows me to do is when I click this button, I just heard it click behind me, but it sent a command through the web, whether I'm here or away, to the Arduino. The Arduino used those signal wires that we talked about, that white network cable. It went to the relay and it triggered the relay on. And I look right now and I see that my network switch just powered on. Gemini relay is the relay for my mount, and NUC and Skyroof relay are the relay controller for my NUC and my Skyroof. So real easily, I'm gonna go ahead and turn off the switch. Real easily, I'm able to power cycle my devices, or more importantly for me, power them off when it's cloudy outside so that they're not pulling power from my batteries all the time. On top of that, I have a router power control. Well, the router is how the entire observatory gets internet. So I never want to power off the router, because if I power off the router, there's no way to power it back on without coming out here and manually doing it. So instead, I made a restart command. Restart cuts the power to the router for maybe a second, half a second. Then it kicks power back onto the router to repower it up and regain control of all my systems. The reason that that's important is sometimes my router just poops out. I would normally have to drive 10 miles out here, restart it, go back home, and continue use. This way I can remotely do this. So again, if you are VPN'd in or locally on the network of your observatory, you can just type in the IP address of your Arduino and have remote access of what you need remote access for. This total cost of this project is probably about 50 bucks, including the wiring, including the relay controller or the relay box, and including the Arduino. Beyond that, it's maybe 20 hours of work to wire everything up, to learn what you need to learn, and to make it happen. So definitely a very doable thing for those of you looking to get remote power control of different devices in your observatory. And this could obviously be carried over to 10, 20, 30, 40 devices. If you want to be able to power control all of them, as long as you splice in a relay on each circuit, you'll be set to go. So hopefully that made some sense to you guys. If you like this video, hit that thumbs up button. If you didn't like it, you know what to do. If you guys want to subscribe for more super nerdy and in-depth content on running a remote observatory, the subscribe button's down there in the corner. And lastly, thanks for watching.